back to the next session of green building course. In the last session, we have been discussed what are the various building materials that we use in the construction of building or we come across in the construction of building. In that have been discussed the number one, that is stone. Now the next we have been discussed the laterite blocks, and the third one we have been discussed the clay bricks or burnt clay bricks, and the next hollow clay blocks. Okay, so these four building materials which have been discussed, okay, along with their characteristics, requirements or properties, and also the sizes as per the IS. So in this today's session, let me move on to the other building materials, okay, other building materials that will be predominantly used in construction. So the next building material you can see, the next building material is concrete blocks, okay, and these concrete blocks nowadays is predominantly used in commercial and industrial buildings as a wall element. That means in order to construct a wall, so these concrete blocks are majorly used or preferably used in commercial buildings or industrial buildings. Okay, these burnt clay bricks which have been discussed in the last session is majorly used in residential building, but nowadays, okay, in the industrial building or commercial building, these concrete blocks are majorly used. Okay, next. So let us move on what exactly is concrete block and all. So as free from the concrete block we can define as, okay, as the name itself indicates, it is a concrete block. That means it is a composition of cement, fine aggregate, that is sand, coarse aggregate and water. So the mixture of all these four constituents will form a concrete block. Is it clear? So let us know what exactly is concrete block. So as per the IS code, okay, we will define what is concrete block. Okay, the codal provision we are going to follow for the concrete block is IS 2185. I think in yesterday's session I have been told or highlighted about Indian standards. That means whatever the blocks we use for construction, maybe size, maybe strength, maybe the water absorption, anything, those characteristics or properties which we have been discussed in the last session, that should be abide by the each block before using it as a construction material. Is it clear? So let us know the definition. So now concrete block is defined as a solid material. It is a solid material, okay, not less than 75% of the total volume of the block calculated from the overall dimension. That means this is a typical technical definition what I wanted to, okay, or just I want it depicted. That means a concrete block, okay, yesterday I think you may remember that I have been defined hollow clay blocks. In that hollow clay blocks I have been defined that 50 to 75% openings is there, okay, that will be called as hollow clay blocks. If there is no opening, more than 75% solid present, then that particular block is called concrete blocks. So that is what the definition meant. Okay, and I have already been told that concrete block is a mixture of cement, fine aggregate, coarse aggregate, that is jelly, and water. Is it clear? So we will move on to this, and one more thing, in this concrete block, okay, we can produce the solid concrete block and also the hollow concrete block. If the hollowness is, okay, more than 75% or 50%, that will be called hollow clay blocks. Okay, if the solid is more than 75%, that means only 25% or 20% hollowness is there, then that will be called as concrete blocks. Okay, that is solid concrete block. So that means the concrete block will be classified into solid and also the hollow concrete block, just like what we discussed in the last session, that is, okay, solid burnt clay bricks and hollow clay bricks. Okay. Next, we will move on to the next. The next is The next is, okay, after discussing regarding the definition of concrete block, now we will move on to the types of concrete block. See, preferably as per IS 2185, they are going to classify the concrete block based upon the density. So, in the yesterday class have been highlighted regarding the density. Increase in density will increases the strength of the block. Okay. Why I am specifying density here? Because in the concrete block we are going to produce both less density block and high density block. Okay. So that means in the construction of wall we will be using both the less density and also the high density concrete blocks. So in that preferably that is grade A. Okay, that grade A is whose minimum block density, you can see from the slide, a grade A, that is these are used as a load bearing units and shall have a minimum density of 1500 kg per meter cube. And this grade A will be having a strength of, I think in yesterday class I have been specified, the minimum compressive strength a concrete block should possess 3.5 MPa. Okay, hence the grade A concrete block should possess a minimum strength of 3.5 MPa, likewise 4.5, 5.5 and so on. The grade B, coming to the grade B blocks, the grade B blocks are also used as load bearing. Load bearing ones that will bear the load of, that is whatever the load comes on that concrete block, that will be bear by these blocks, that is called load bearing units. Okay. And this load bearing units will be having, that is grade B load bearing units or blocks will be having a density of 1100 to 1500 kg per meter cube. That means anything between the density 1100 to 1500 kg per meter cube will be called as grade B, okay, density blocks, or I can say concrete blocks. And this will be having a compressive strength of minimum 3.5 and also 5 Newton per millimeter square. That means if I talk regarding the preparation of this concrete block, okay, this already been told that this is a mixture of cement, fine aggregate, coarse aggregate, all those things. Okay. And after mixing all these things in a particular mixture, okay, they are going to cast it to a specific size, okay, which I am going to discuss next. The sizes they are going to manufacture are available in the markets are 4-inch concrete block, okay, 6-inch concrete block, 8-inch concrete block. So usually they are going to talk in the market inches. 4 inches means 100 mm concrete block, the thickness, okay, and the 6-inch means, okay, that is 125 mm likewise. Okay. So these are the different thickness of concrete block they are going to manufacture. So after that means after casting this or mixing this cement, fine aggregate, coarse aggregate and water in the mold, okay, they are going to remove that whatever the mixed concrete after 24 hours and they are going to immerse in the concrete block, immerse the concrete block in water for 28 days or 21 days, okay, in order to get, okay, curing. That means if there is no curing, that means if you are not going to do the curing means, okay, that means I am initiating the process of, okay, if the concrete block wants to attain strength or require density means we need to cure it from water. That means it is something like a food we are feeding to the concrete block. Okay, without food, how we are going to die? Like that the concrete block also requires certain amount of food, that is water. Okay, it will consume water in order to attain a required strength. Is it clear? So, till 28 days I am going to cure the concrete block. Okay. After curing for 28 days, the concrete block will be tested for a strength. The strength attained in this grade B is 3.5 and 5 MPa. Here also the minimum strength is 3.5, okay, MPa, that is Newton per millimeter square. Next, likewise the grade C. The grade C will be having a density, okay, not less than 1800 kg per meter cube. Okay. The grade C block is 1800 kg per meter cube, okay, and the compressive strength is 4 and 5 MPa. You can see that. Okay. So that means IS 2185 has classified the concrete blocks based upon the density and the compressive strength. Okay, the density, I think have not been highlighted. The density will be calculated, we know from the basic elementary formula, mass divided by volume. We know the dimension of the block. Okay, that means I have been highlighted 1800, 1500 kg. How we are going to calculate that? That is mass by volume. That is, okay, we know the dimension of the block. Okay, calculate the volume. Weight, you will get a K, okay, the whatever the weight. So that is kg per meter cube will give you the volume. That is mass divided by volume or weight divided by volume. Is it clear? And when I am going to apply certain amount of load on that block, it will undergo crushing. Okay, so after getting crushed, whatever the load that is going to get rupture or break, that load divided by the cross-sectional area will give you the strength. Is it clear? That is what compressive strength. So the IS 2185 has classified the blocks into grade A, grade B, grade C based upon this density and strength. Is it clear? Fine. So next, as I am highlighted, so from next slide you can see that the material used for concrete block as per IS 2185, I think have been mentioned. The first basic material is cement. Okay, a cement we need to use. Okay, nowadays in the market, okay, there will be different types of cement. I think company you already know, but types of cement is different. Okay, which I am going to highlight upon this. Okay, that is ordinary Portland cement, OPC, ordinary Portland cement, and also the one more type predominantly used is Portland Pozzolana cement. Portland Pozzolana cement. So what is the difference between these two? Okay, I think in yesterday class I have been highlighted. OPC, okay, will releases enormous amount of carbon dioxide or greenhouse gases. Okay, in order to mitigate this, what I am going to do, I am going to use a industrial byproducts or waste. I think yesterday I have been told that carbon capture and all those technologies. So we can minimize the carbon dioxide, okay, the release of carbon dioxide by replacing the cement by some percentage of fly ash. Okay, that means preferably I say fly ash. This fly ash is predominantly used as a replacing material for cement. That's why, okay, this fly ash is called pozzolana, and when I am going to replace pozzolana to the cement, that will be called as Portland Pozzolana cement. Now comes the fly ash. How we are going to get the fly ash? Okay, this fly ash will be obtained when I am going to burn the coal at a temperature of 1000 degree or 1500 degree centigrade. Okay, to this temperature if I am going to burn the coal, whatever the residue left out after burning the coal, why we are going to burn the coal? The coal will be burned in order to fulfill our needs, that is particularly to generate the power. To generate the power we are going to burn this coal. After burning, whatever the residue that is left out, okay, that ash, okay, which is going to get fly because of the lesser weight or lesser specific gravity, okay, in which we are going to collect it and we are going to store, and later on this residue or industrial byproduct, okay, can be replaced as a cement so that we can minimize the carbon dioxide. So this is what the process, okay, that is available in the market nowadays. One is ordinary Portland cement, no pozzolana replacement. PPC means Portland Pozzolana cement, which is replacing. I think nowadays there is n number of companies are coming up, that is Ultratech cement, Zuari cement, ACC cement. All these people are now looking into the aspects of go green concept. Even JSWO, everyone is looking with the go green concept. Is it clear? That means try to minimize the carbon dioxide by replacing the industrial waste. So by this we can achieve the go green, that is the green concept or carbon footprint. Okay, is it clear? So this is what regarding the cement. So in order to manufacture the concrete block, okay, we can use OPC or we can use PPC. If you want to go with a green concrete block, go with PPC. That's it. Okay. Likewise in the Jindal also, the Jindal industry, it is a most famous industry that is available in the Ballari, which produces the steel. Okay, there also the steel industry, the Jindal will produce a waste called granulated blast furnace slag. That means after burning the coke or iron in the blast furnace slag, the residue left out will be the granulated blast furnace slag. When I am going to ground it or grind it, okay, the fine to the finer of cement, okay, that particular material also can be replaced. The Jindal is coming up with this replacement of cement with the ground granulated blast furnace slag as Portland slag cement. Okay, so these are the the types of cement that is available in the market, so that PPC, by using PPC and PSC, we can achieve the concept of green in the cement. Okay, in turn we can reduce the global warming and carbon dioxide emissions from the building also, because I think in yesterday class have been highlighted whatever the carbon dioxide that will be involved in the material, because when I'm going to use a OPC block, the carbon dioxide will be very high. Automatically, when I'm going to construct the building with OPC cement, automatically the building will also get the more carbon dioxide. Yeah, that means it will release more carbon dioxide. If you want to mitigate this, if you want to go with a green building, then what I should do, I need to use a cement with PPC or PSC, so that I can bring down the level of carbon dioxide by attaining the green concept in the building. That is what I wanted to say in the green building concept. One is material wise, we need to minimize, consume less natural resources, use more industrial byproducts, and another thing, construction practices. So these construction practices I am going to discuss in module number 2. In this module number 1, I am going to discuss entirely regarding the materials, the various building materials we are going to use in order to construct the building. Is it clear? Next, after coming about the cement, that's aggregate. I think I have been told the aggregates, that is both fine aggregate and coarse aggregate, they are going to use, apart from cement. Next, as I told, water, that is the predominant use, because water will be used, we need to be very cautious in this, because whatever the water which is fit for drinking, those water only we need to use it for concrete. Why? Because if the water contains some deleterious substances, for example, if it contains more chloride, more other chemical and all those things, it will damage the concrete. So in order to overcome this, what I need to do, we need to test the water before we are going to use, and that's why whatever the water which is fit for drinking, so those water we can use it for the the construction, or we can for the production of a concrete block. Next is additives or admixtures, we can see. So these admixtures, why I am going to add? Because in order to make a concrete more plasticity, in order to make a more flow, because if I want to mix it, the concrete block easily, what I need to do here is, I need to go ahead with the process, process in such a way that these admixtures will help you out, and that is one thing. The second thing is we can minimize the water content. Why? Because if you increase the water content, then the density will be decreased, because voids will be more, automatically the density will be decreased. If density decreases, the strength also decreases. That's why in order to reduce the water ratio, on that particular place, we can use admixtures, in that place. So by using the admixtures, we can bring down the water level so that we can attain a workable concrete block, and to the required shape and size. Is it clear? So these are the materials we are going to use: cement, aggregates, water, admixtures, and so on. So coming to the next is, physical properties or characteristics the concrete block should possess. So I think in yesterday class also, yesterday session, there is last session also, we have been discussed that what are all the characteristics or requirements or property burnt clay bricks or hollow clay blocks or a laterite blocks or a stone should possess. Likewise, in the concrete block also, we need to look into the characteristics or requirements or properties. Number one, dimension, that have been discussed. The dimension you can see, it may be 400 mm, 500 mm, 600 mm, and height, that is what the thickness which have been highlighted. 200 mm, that is 8-inch thickness, 100 mm, 4-inch thickness, and also sometimes we go with a 6 inches also. Okay, that is 150 millimeter. Okay, 4-inch block, 6-inch block, because in the market we are not going to use in the millimeter, we are going to use it in inches. Okay, so that is 1 inch is equal to 25 millimeter, therefore 4 inch means 100 millimeter. Next, width, we can see 50, 75, 100, 150, 200, 250 and so on. Okay, and the next, density, I think already been discussed, block density. A density will be varied based upon grade A, grade B, grade C. Grade A, I think it is 1500, grade B 1000 to 1500, and next grade C 1800 kg per meter. Okay. Next, water absorption. The water absorption value, okay, of the block should not be more than 10% by weight. It should not be more than 10%. I think I have not been told regarding how exactly the water absorption will be conducted. The water absorption will be calculated by, first take a required size of the brick, okay, take a weight of that block, immerse it in the water for 24 hours, okay, then take out, okay, drain off the water and take the weight, okay, that means first day you will take dry weight, okay, that means completely remove the moisture and take the weight. Second day immerse it in water, that means the first day itself immerse in water, and second day take out from that water and weigh it, you will get the wet weight, okay, after immersion. So therefore, wet weight minus dry weight divided by the wet weight into 100 will get you what? What is the water absorption percentage? Okay, into 100. That is the water absorption value in percentage. That means the water absorption value should not be more than 10%. You can see next, that is the compressive strength which have been discussed based upon grade A, grade B, grade C. You can see what is the minimum compressive strength it should possess. You can see that classification. I think I have been highlighted over there, hollow concrete blocks and solid concrete blocks. Okay, that is grade A and grade B are hollow concrete blocks. That's why the density was very less, 1500 and 1100 to 1500. Grade A and grade B are hollow concrete block. Grade C, that is the block density minimum it should possess 1800 kg per meter cube. It is a solid concrete block. Is it clear? So those solid concrete block, you can see, okay, the hollow concrete block should possess, I can say, the minimum compressive strength based upon the grade A, grade B, grade C. So solid concrete block should possess a minimum compressive strength of 5 MPa. Is it clear? Likewise, next, shrinkage. Shrinkage is a very, very important phenomena, especially in the concrete block. Yesterday, I think I have been told or defined, shrinkage means change in the volume of the concrete block. It may be height, it may be length, or it may be width. Why? Because of the presence of moisture inside the concrete block. Because of presence of moisture inside the block or absorption of moisture from the, okay, atmospheric condition, the concrete block will undergo, okay, the variations, what is called shrinkage. Okay. So next, coming to the next slide, that is advantage. What are all the advantages of concrete block? So the advantage of concrete block is rapid execution of work. Okay, that means we can finish off the construction of wall very fast compared to the burnt clay bricks. Why? Because the size of the concrete block is big. That means if you want to construct a 1.5, okay, brick wall, okay, by the time we can construct one brick wall or one concrete block wall itself. So that is a scenario. That's why rapidly we can construct the wall using concrete block. Next, increase in floor area. Okay, so that means if we use, for example, this is very important. When you want to construct a building, okay, if you use a hollow concrete block, okay, a 4-inch wall or something like that, those 4-inch wall will increase the floor area because compared to 6-inch, 4-inch will occupy less space. Okay, therefore, the availability of floor area is more. Did you get my point? If you want to go with a more floor area, then reduce the thickness of the concrete block or size of the concrete block, go to the 4-inch. Is it clear? So by this, we can increase the floor area because we are going to manufacture to the various, okay, sizes of the concrete block. Okay, by that. Okay, next, reduces construction cost. Okay, that means the hollow blocks, you can see that helps in saving construction material. Okay, and therefore use of hollow blocks reduces construction cost. Preferably, as I mentioned in the yesterday class, this hollow concrete block is a, what I can say, less load bearing member, or I can say non-load bearing member. Okay, these non-load bearing member, because solid block concrete is called, concrete block will be called as load bearing units, hollow concrete block will be called as non-load bearing unit. That means it will bear the load very less. Okay, hence this hollow concrete block we can use it. And another important thing, if you want to, okay, divide the wall into two halves or two rooms, then preferably we can go with the hollow concrete blocks, which is more preferred, because though hollow concrete block without, okay, any carrying the load, okay, it can bifurcate the wall. That means whatever the load coming on that, okay, the solid block, okay, we need not to worry here in the hollow concrete block. Okay, so they can use it for the partitions. Next, better insulation property, especially in hollow concrete blocks, because more the hollowness, okay, better will be the thermal insulation property. For example, if you construct a wall with a solid concrete block, whatever the heat that will be dissipated, okay, dissipated inside the room will be more compared to the hollow. Is it clear? So that's why you prefer more hollow concrete block rather than solid. If you construct a wall, okay, with a solid concrete block, if that particular wall facing towards sun, then that okay, wall will receive more heat, Okay, obviously inside the room you will feel more warm. Is it clear? If you want to reduce this, go with a hollow concrete block so that you can reduce the temperature inside the room, okay, and we can modify. This is what the very important thing in the green building you need to look. Okay, orientation of building to the atmospheric condition. When you go into with the cold countries, orient your wall in such a way that we can receive more heat. Okay, in the hot countries, orient your wall in such a way that you can receive less heat inside. This is what one of the concept of green building we need to look at. Is it clear? Next, more durable. Okay, the durability is very high compared to the burnt clay bricks, laterite blocks, stones. Okay, because the compressive strength will be very high, hence the durability will also be very high. Okay, employment of unskilled labor, no skilled labor are required. Okay, you can train it very fast and you can prepare the blocks. Next, good bonding. Okay, that means whatever the mortar which I have been told, that means we are going to lay on above the concrete block, that is a mixture of cement, fine aggregate and water. Concrete means cement, fine aggregate, coarse aggregate and water. Mortar means cement, fine aggregate and water. And one more thing, very important thing we need to look into these blocks is, compared to the burnt clay bricks and okay, laterite blocks and all, or stones, okay, in this concrete block, the finishing will be very smooth. That means the concrete block having a surface finish very good, okay, and so that we can plaster with a mortar very neatly. Okay, so that is an advantage with respect to the concrete block. Is it clear? So this is regarding your concrete block which I wanted to highlight. Okay, so I hope you have understood regarding the concept of concrete blocks. So let me move on to the next, stabilized mud block. Okay, so from now I am going to talk with respect to the, that means this is the block, that is block, it is a green product. It is a green product which I am going to highlight now. Okay, so it is a best alternative to the clay bricks. Okay, I will tell you what are the alternatives, that means how exactly it will become an alternative. See, this stabilized mud block is come up with an idea, that has been initiated an idea in such a way that we can reduce the use of burnt clay bricks. Why? Why we need to reduce the burnt clay bricks? Because two reasons are there. One is, if we are going to produce a burnt clay bricks, we are completely damaging the nutrients of the soil when you are going to remove it, okay, on the topmost layer. Because in yesterday, okay, that is in the last session of video, I have been told that remove 200 mm depth soil, okay, that particular depth contains high amount of nutrients, okay, which is essential for plants. that we are going to remove it. So that's why in this, okay, we can come up with this alternative, try to utilize it, okay. And the next, okay, that advantage, or I can say this, burnt clay bricks is, that is disadvantage is, or the second thing is regarding the burning. So these burnt clay bricks requires, okay, burning process. Okay, why? Because I think in the last session I've been told that while producing the burnt clay bricks, it demands heating. Without heating, you won't get any strength. Without heating, you won't get any strength. Hence, the clay bricks demands heating. That means one is you need to use a fully soil, okay, and another one is the heating process. And another drawback of this clay brick is, if you want to produce more compressive strength, just like a concrete block, we cannot produce because it is a completely soil material. Okay, so because of all these reasons, okay, we need to come up with a product in such a way that we can overcome all these, okay, the problems. Okay, if you are going to overcome all these problems, we can come up with a beautiful product. So with this, let me go to the next, okay, block, that is stabilized mud block. Stabilized mud block. So what is the meaning of stabilized mud block? Let me see. So you know what is the mud? Mud means soil block. What is the meaning of stabilize or stabilization? First let me define, later on I will go to the other things. So first, stabilization of soil. As I told, mud block, we are going to predominantly use to manufacture the stabilized mud block is soil. So stabilization of soil is alteration of one or more properties of soil. What are those properties? For example, if you want more density, if you want more strength, okay, if you want to make more impermeable, if you want to make more durable. Did you get my point? So if you want to get a very good properties compared to the clay bricks, okay, then, okay, I need to alter it. How? By mechanical or chemical means. By mechanical or chemical means. Mechanical means, okay, the mixture of soil, okay, the mixture of soil means which you are going to produce a SMB, that is stabilized mud block, okay, will going to get compacted. That means layer by layer I am going to compact the soil to produce, okay, the stabilized mud block, or I can say the press, okay, the machine press, okay, will induce the compaction. That is what the mechanical way, because I told that you can minimize the voids by doing the proper compaction. Okay, if we do the proper compaction, okay, the density will be increased. With increase in density, okay, we can increase the strength of the block. Is it clear? Next, chemical way. Chemical way means by adding agents. For example, it may be lime, okay, cement, okay. That means, for example, if you're going to take a 1 kg of soil, okay, for 1 kg of soil, try to, okay, use cement as an additive. Okay, there is a difference between alternative and additive. Alternative means replacing. Additive means adding extra. Okay, this cement will be added extra, okay, to the 1 kg or whatever the soil in order to produce the stabilized mud block. Okay, that means this cement will initiate the chemical process inside the soil so that we can achieve good dense, good strength, impermeable. Impermeable means no water can penetrate inside. If water penetrate inside, automatically the block will be damaged. Okay, so all these properties we can achieve. Okay, so that is what the definition mechanical or chemical means. To create improved soil possessing dense engineering properties. Okay, that means in order to get a good engineering properties in the blocks, what we are going to do is do the process of stabilization by chemical way or mechanical way. That is compacting or adding additives. So this is what the mechanism I am going to do in order to get the stabilization process. By doing this stabilization process, we can prepare a block which is called stabilized mud block. Did you get my point? Okay, adding cement or lime to the soil, that is chemical way. After addition, okay, we can go with the compaction. Okay, so by doing these two things, the stabilization process we can achieve. Okay, by doing this stabilization process, okay, I can go with the stabilized mud block. Okay, so that's what I've been highlighted over there. Okay, the soil may be stabilized to increase strength and to prevent erosion. Next, the two methods, that is mechanical way, another one is chemical way. Is it clear? So this is what the stabilization process. The most common form of mechanical stabilization, that's what I've been highlighted, compaction. The mechanical way of stabilization of soil is compaction. Okay, by doing a compaction, okay, we can achieve the good stabilized mud block. Next, I've been told that chemical way is adding cement, lime and other agents, okay, as an additive for soil stabilization. By doing this, we can achieve the or produce the stabilized mud block. So adding cement, adding lime, doing compaction, all these things will not be done in the case of burnt clay bricks or hollow clay blocks or laterite blocks. Did you get my point? Simply put it in the mold, okay, eject it, okay, burn it and use it. That is what the burnt clay bricks. Even the laterite blocks also. Mix it, make a cake, take, okay, then cut it to a required shape and size, dry it and use it. Did you get my point? So here the process is entirely different, where we can get a very good engineering properties such as good okay, density, strength, impermeable and so on. Okay. Next, that's what have been highlighted. Okay. Now coming to the process of raw materials. So what are the, how to produce this stabilized mud block? Okay. So let me go first with the raw materials. So what are the raw materials required to produce the stabilized mud block? The raw material required are soil. Okay, the first. This soil contains silt, clay and sand. I think, hope you know that clay soil. Clay soil means where we are going to do the idol of Ganesha. Okay, so it is what clay soil. Silt, okay, and sand. The sand will be preferably used in preparation of concrete. Did you get my point? Next, it is preferred that the clay should be non-expansive. Okay, whatever the soil we are using, it comprises of clay. That clay should not be non-expansive. That means it should not get contract or expand. Okay, that is what non-expansive. Next, generally the soil contains 10 to 15% clay. Okay, how much percentage clay and how much percentage sand, that has been mentioned. The soil should comprise 10 to 15% clay and 65 to 70% sand. Is it clear? And are satisfactory for making SM fluid. Okay, so 10 to 15% clay and 65 to 70% sand is required to manufacture the SMB block. Next, cement is the additive. I am going to use it as a chemical stabilizer, okay, in which I am going to add 6 to 8% by weight of soil. Okay, 6 to 8% by weight of soil I am going to add it. Next, another thing, a very important thing we need to be noted down is, if the soil contains more amount of clay, for example, if it contains 20, 25% or 30% clay in the soil, then that particular, okay, soil cannot be used in SMB block. We need to do the alteration. How can we do the alteration? That alteration we can do it, okay, by adding, okay, the quarry dust. The quarry dust is nothing but, okay, the waste generated during, okay, the blasting or during the process of quarrying of stones. So that is what I can say, the quarry dust. So these quarry dust we can use it, okay, in order to reduce the clay content. That means what I want to try to say here is, okay, decrease the clay content and increase the sand content, okay, so that it will be well balanced. Okay. Next, a combination of lime and cement can be used for non-expansive soil. Okay, clay content around 15% and cement around 5%. That is what thing I can, okay, that is optimization of SMB. That means use 15% clay, 5% cement, 2% lime and remaining sand. Okay, then we can go ahead with a good SMB block. So that means why we are using a lime, because the lime, if you are going to use a lime, okay, inside the soil, it can increases the durability. But we need to keep in mind the lime should not be more than several prescribed limit. If it is more than the prescribed limit, it may start, okay, leaching problem or some other problem. Okay, so that's why we need to be very cautious regarding the, okay, production of this SMB block. Next, coming to the manufacturing process. Okay, now we came to know the raw materials. Now we will move on to the manufacturing process. Okay, first sieve the soil. Okay, sieve the soil in 4 mm IS sieve. Why? To remove the stones and lumps of clay. Mix the sand or quarry dust, okay, with respect to the soil. That means if it contains more clay, add sand or quarry dust. Add cement, okay, and lime in appropriate proportion, that is additives, in order to do the chemical stabilization. And later on, don't add water, sprinkle the water. Okay, whatever the device that is going to be used in gardening, that I am going to showcase now, okay, that is what the device we need to use, okay, in the production of SMB block. Next, after adding this sprinkler, that is moisture, okay, from the device, next, okay, see to it whether you have attained the required consistency or not. Okay, that means if that water is more, you cannot produce a good SMB block. If water is less, then also we cannot produce a SMB block. So in order to check the optimum moisture, what we are going to do here is take out a small sample of mixture of soil and water. Okay, make a ball out of it. Make a ball out of it. If that mixture does not stick to the palm of your hand, then I can say it has attained OMC or optimum moisture. Okay, if that particular sample is sticking to your palm, then we need to do the mixing part. That means the water content is more. We need to manipulate it. Did you get my point? So that's why while adding the spring, that is water, we need to be very careful. We need to keep on add little bit and check for the OMC. And then if you add more water, if it is very sticky, then I need to do the lot of corrections over there. So we need to be very cautious. Next, then after mixing, after attaining OMC, okay, then pour that material inside the mold, okay, and then press it. Okay, we are using the machine called Mardini press, which I am going to show you now. Okay, Mardini press is the machine. That Mardini press machine is predominantly used to manufacture the SMB block. Okay, and this machine costs very less, maybe 1 lakh. But in order to make a brick furnace, to produce big brick, it is a huge investment. See, SMB block doesn't have that much investment. Okay, locally available soil, cement, a small percentage of cement, okay, and a good equipment costing around 1 lakh or 120. Okay, then pour it inside the Mardini press, press it, and the labor requirement is also very less. Just a 1 or 2 persons is enough to operate the machine. Okay, just press it, eject the block, keep it, okay, then cure those concrete block for 21 days and it will be ready to use product. No burning, nothing is required. Is it clear? So this is what the production process of SMB block, that is stabilized mud block. So I got a photo to show you. You can see that. Okay. See, in the first photo, you can see that he is preparing the sand. Okay, he is preparing the sand. That sand contains, soil contains, okay, that in the first photo, soil contains sand, silt and clay to the required percentages. In the second photo, you can see that, okay, he is mixing a cement. Then, in the third photo, in the left corner, you can see that he is mixing uniformly both cement and soil, that is additive and soil. And in the fourth photo, you can see that he is sprinkling the moisture. He is sprinkling the moisture. Is it clear? we need to sprinkle it. We need not to add the water. If you add more water, then we cannot use that for the production of SMB block. Next, mix it thoroughly. Okay, you can see that. Then the fourth, that is the next second photo, you can see that he is pouring that mixture inside that Mardini press. That is what the Mardini press. Okay, after pouring, close the lid of the machine. Okay, then, okay, you can see on the last photo, one person is just pressing that, okay, that whatever the block, and then eject it. Okay, in the next, eject that block. In the next slide, you can see that. Eject the block, SMB block. Okay, keep it for drying. Okay, he is checking the size of the block, whether it is attained the required shape or not. Okay, and size or not. Okay, then allow it to cure it for 21 days and then go ahead with the construction process. So this is a completely go green concept. Okay, in this we can make some more green by replacing the cement with fly ash. Instead of using completely cement, we can go with the cement plus fly ash. So there also we can minimize the cement content. Did you get my point? Okay, or else you can go with fly ash and lime combination. Did you get my point? Why? Because we cannot use only fly ash, because fly ash is not a cementitious material by itself, or it is not a, which is a pozzolanic material, which is not a cementitious material itself. That means if I mix a water and a pozzolana, that is fly ash, it will not form a paste. Why? Because it doesn't contain any calcium. Did you get my point? That's why we cannot use fly ash alone. We need to use a combination, cement and fly ash or fly ash and lime. So the lime content should be there. Then only the fly ash will react and give a good performance. Is it clear? So coming to the strength, okay, you can see that the SMB technology is well suited to produce range of block strength at the site. And another interesting thing here about this advantage of SMB block production is you can carry this machine wherever you want. It is portable. Okay, you can prefer or fix it in the site itself. You can produce the block there itself and we can use it. That is the interesting thing. No need to go for transportation, because if the burnt clay bricks or hollow clay blocks, okay, we need to burn it in the furnace or in the place, and then we need to transport from that, okay, place to the particular site. It requires so much of energy. Okay, but here we can, it is a portable, since it is a portable machine, we can take the machine and fix it in the site itself and we can go with the preparation of SMB. Next, here also, okay, the minimum compressive strength, okay, the SMB block should possess is 3 MPa, and using this SMB block, we can construct up to 2-story building without any column. Without any column, we can build 2-story. Okay, I'm going to show you the photo, okay, the next, okay, so that they will understand how exactly the stabilized mud block building looks. Okay, so use high percentage of cement, that is wet compressive strength in the range of, that means another thing is, if you increase the cement content, obviously you can increase the strength of the SMB. For example, if a client demands more strength in the SMB, increase the cement content. Instead of using the 4%, 5%, go with 8%, 6%, something like that, so that we can achieve more strength and also the density. Is it clear? And if you want to make it a green product, replace cement by fly ash. Okay, so that is what the thing. So this is what the typical, okay, the table which I wanted to show you, very good table. Okay, this clearly indicates the composition. Sand 65, you can see from the slide, sand 65, okay, the silt 18 and the clay 17%. Okay, this is the combination. I am preparing the specimen 76 by 76 by 76. And one more thing, we can prepare the assembly block of bigger size, more than burnt bricks, so that we can save the time in the construction of a wall. You can see 2.5% cement content is added. You can see the compressive strength achieved is 4.54, 5, 9.20, 7.5, 11.6, 100, 15 MPa. That means completely replacing the soil with the cement. 15 MPa we can achieve. So that is not, 100, it is 10% soil. Okay. So 2.5, 5, 7.5 and 10%. Okay. So by replacing this percentage, we can achieve the compressive strength. There I think you can see dry and wet. Usually when the block is wet, it is not properly dry. If contains some amount of moisture inside the block, then obviously the compressive strength will be decreased. Hence, we need to remove the moisture inside the block and we need to conduct a test. So there you can achieve the more compressive strength. Next, coming to the advantages. Advantages is independence and availability. Okay, that is mud is available, no need to depend upon, for example, if I want to prepare a concrete block, cement is required. If you want to produce cement, abundant limestone is required. But here, I don't want to depend upon this. Locally available soil is enough. And the locally available soil is abundantly available, so hence it is independent and available. Next, shipping cost. Okay, that means suitable soil is available nearby the site, so no need to worry about this. Next, uniformity. SMB can be manufactured to a predictable size and has 2 flat size and 6. That means we can produce this SMB block to the preferable size and shape. Okay, no need to get warping. That means yesterday in the last session I have been told that warping effect means okay, unevenness in the block. So those unevenness we cannot see in the SMB block. Next, non-toxic. Okay, it is a non-toxic because no external agents are present. Okay, next, sound resistance, a very good thing. Okay, it will absorb the sound. Okay, next, fire resistance because it is a completely earthen material, hence it is a very good fire resistant material. Okay, insect resistant or termite resistant material also. So these are all the, okay, I'll say advantages. Okay, one can look at it. Coming to the next, this is a photo where you can see a G+1, okay, and I think one more story headroom is there. You can see that, okay, 2 or 3 story building completely built with a SMB block. You can see that. And you can see one interesting thing about that building. Anyone can observe? The interesting thing about that building is no plastering is done on that. That is the advantage of the SMB block. Because of the smooth finish in the SMB block, okay, the thing is it doesn't demand any plastering. So no plastering is required in the, okay, the building. No plastering is required in the building. So hence, this is the advantage in the SMB block where we can go ahead with the construction of a building. And one more building you can see, the G+1 building. So another building we can see that. Okay, here also no plastering is done. You can see how aesthetically it is looking good. You can see that. Is it clear? Next, the one more photo which I wanted to show you is, this is a hollow SMB block. You can see that. You can also prepare hollow SMB block. In that hollow portion, you can see that the reinforcement or steel has been inserted. Why? Because if you want to increase the strength of a wall, okay, we can go with the reinforcement. That is called a reinforced brickwork. Okay, regarding this, I am going to talk in the next module, that is module number 2. Okay, how to construct the wall. Okay, what are the different types of wall I can construct. All those things I will teach you. In this module, okay, we will just know about the different material that will be used in the construction of a building. Okay, so this is about the SMB block which I wanted to discuss. Okay, which I wanted to highlight regarding this. Any doubts you can ask. Is it clear? Any doubts? Okay, so hope that our concept has been clarified. Okay, I think till this have been covered various types of blocks. Okay, I have been discussed starting with stones. Okay, later on I went with the burnt clay bricks, hollow blocks, laterite blocks, and in this session I have been discussed laterite, okay, that is stabilized mud blocks, concrete blocks, okay, these two things. So these are the different types of blocks that are available, and predominantly used blocks in the market are burnt clay bricks for residential building, concrete blocks for, okay, the commercial buildings, or I can say institution building. For example, for college, industries, apartments, complexes, okay, for all those things we can go with the concrete blocks, okay, where we can increase the floor area, where we can increase the strength of a building. So when you go with a high-rise building, it is preferable to go with concrete blocks and preferably hollow concrete blocks rather than going with burnt clay bricks. And these concrete blocks, they are going to preferably use between the columns. Okay, that is called as frame structure. So in between the columns, okay, I am going to fill up these blocks. That is called masonry infill. Whatever these blocks, bricks, okay, which have been discussed, without column also we can use it. That's what have been highlighted in the assembly blocks. Without any column, we can construct up to 2 floors with a wall, with a block itself. If you want to go with a high-rise building, for example, 10 floor, 20 floor, we cannot go with only with the blocks. We need a supporting actor. That supporting actor or strengthening factor is column. So between the 2 columns, we can place this wall, okay, and we can go ahead with the construction practice. Okay, so any doubts? Hope the concept of blocks has been covered. Okay, with this, okay, I am going to end the session of this today. So we will discuss some more materials in the next session. Thank you.